Good day, engineers. Para sa video natin ngayon, ang i-discuss natin will still be the ultimate bearing capacity for eccentrically loaded shallow foundation. So, dito sa video na itong i-discuss natin is yung right hand rule and kung ano nga ba yung one-way and two-way eccentricity. So, let's start this video. So dito, una nating i-discuss yung right hand rule. Yung right hand rule, this is just a review. This is tackled on your statics. Yung right hand rule kasi, ito yung ginagamit natin, yung kanang kamay natin para makuha yung mga axis dun sa structure natin, and ito din yung ginagamit natin para makuha yung mga signs ng rotation or movements dun sa ina-analyze natin. So, the most common is such that yung ginagamit ni STAAD. Si STAAD kasi, ang ginagamit niya is X and the Z is the horizontal, tas yung Y is the vertical axis. So, kung gagamitin natin yung right hand rule as shown in this figures, so kung mapapansin nyo, ito, so yung hinto to roo, siya yung naging z-axis, and yung middle finger ko, siya yung ginawa kong x-axis, and kaya nakatutok yung hinlalaki ko on this side kasi siya yung magiging y-axis natin. So, parang nakaganon yan. So, yan yung magiging y. Which is, ang ginagamit ni STAAD na global axis niya for our analysis is ito. So, nakababang ganyan. So, yung z-axis nakatutok ng pagganito, ibig sabihin yan yung positive axis. At yung x-axis is nakatutok on its right side. So, ito yung ituturo sa atin nung mga daliri natin. Yan yung mga positive axis nung STAAD. So, ibig sabihin, yung positive axis ni STAAD for the y-axis is pataas. Kasi pag ganyan siya. So, yan ngayon yung right hand rule for the axis na gagamitin din natin sa analysis nung footing natin. So, susundin lang natin dito kung ano yung axis na ginagamit ni STAAD, which is ito. So, ang ginamit ko pa rin dyan is yung aking right hand. So, para naman dun sa moment. Sa moment kasi ginagamit pa rin natin yung right hand rule. So, alam natin na kapag positive yung moment, kapag 2D lang, alam natin yung rule na kapag pinangiti niya yung beam, so ibig sabihin, lahat ng rotations na pag ganyan, positive. Pero kapag nakasimangat yung beam, lahat ng rotations na pag ganyan is negative. So, with regards to the right hand rule, hindi ganun yung case. So, ang case sa right hand rule is tinitignan natin kung saang axis nandun yung thumb natin. So, para ma-explain yun, we have this figure. So, kung susundin natin yung axis ni STAAD, and kung mapapansin nyo dito sa mga binigay kong figure, so, kung meron tayong moment about the x-axis, ibig sabihin pag about, umiikot siya on the x-axis. So, mapapansin nyo, dinrawing ko na yung proper rotations na makikita natin using my right hand. So, kung mapapansin nyo, this is a moment about the x-axis and this is also a moment about the x-axis. Parehas sila nun. Pero ano yung pinagkaiba nila? Kung mapapansin nyo, dito sa drawing ko on the left side, yung right hand ko, yung thumb niya is nakatutok on the positive x-axis. That means this rotation of moment about the x-axis is a positive mx or a positive moment about the x-axis. While yung kabila naman, kung mapapansin natin, yung thumb niya is nakaturo on the negative side of the x-axis. Ibig sabihin, this one is a negative moment about the x-axis. So, doon natin nakikita yung direction or yung sign ng moment due to the location kung saan nakaturo yung thumb natin on our right hand. Tapos, yung pagka-curl nung natitira nating mga daliri, doon yung direction nung arrowhead. So, mapapansin nyo, ayan. Then, nag-curl dito. So, ibig sabihin, pag ganun yung moment. So, ito yung arrowhead niya. So, yan yung moment about the x-axis. How about the moment about the z-axis? So, lagyan lang natin to ng indications that these are moment about x-axis. So, next, punta tayo dun sa moment about the z-axis. So, ito siya. So, this will be the moments about the z-axis. So, as you can see here, sa moment about the z-axis, so, the rotations will be about the z-axis. So, ibig sabihin, pag ganyan siya, so, this is moment about z. And this is also a moment about z. So, ganun pa rin naman yung rule about this moment using the right hand rule. So, for this moment na nakita natin on its left side, nakaturo yung thumb natin on the positive z-axis. So, ibig sabihin, this one will indicate a positive moment about z. While yung nasa right side natin, which is ito, this will indicate a moment about or a negative moment about the z-axis. Kasi yung thumb natin is nakaturo on the negative side of the axis. So, ibig sabihin, ang tinitignan natin dito is yung global axis na ginagamit natin. So, ang ginamit ko kasi dito is kagaya nung sa staad na axis. Pero kapag nagbigay sa problem, kung nasaan yung z, nasaan yung x, or nasaan yung y, yun yung susundin natin. Kasi that is given by the problem. Pero as a default, we will just use the staad global axis for our problems. So, kagaya nito, ginamitan naman natin ng right hand rule yun. So, that will be the concept for our right hand rule. So, this is just a quick review para dun sa right hand rule natin kasi gagamitin natin yan for our problems and also magagamit din natin to for our design topic. So now let's proceed dun sa tinatawag natin na one-way eccentricity. Tinatawag natin siyang one-way eccentricity kasi nga isa lang yung eccentricity niya. It's either about the x-axis or the z-axis. So, ibig sabihin, pag one-way eccentricity, meron ka lang ding makikitang isang moment. So, one-way eccentricity is meron ka lang ding isang moment. It's either a moment about the x or a moment about the z-axis. So, as you can see on our figure, nagkaroon tayo ng one-way eccentricity because yung columns natin is nag-deviate on uh, the center of gravity ng footing. So, ibig sabihin hindi nag-coincide yung center of gravity ng column and yung center of gravity ng footing. Pero nag-coincide yung x-axis nila. The problem is, hindi nag-coincide yung z-axis nilang dalawa. Kaya nagkaroon ng eccentricity along x. So, nangyayari din yon kung ang columns natin is nandito, tapos nandito, or nandito. So, yun yung mga possible positions ng columns na may one-way eccentricity. And also, kung meron lang tayong iisang moment about z, so yan, one-way eccentricity yan. At meron tayong iisang moment about x. So, yan yung one-way eccentricity. So, for this sample figure, yung rotation natin is papuntang pa ganun. So, that is a moment about z. So, ibig sabihin, a moment about z, which is equivalent to the actual load times EX. As you can see, ang pinoproduce na pinoproduce na moment ng eccentricity X is a moment about the z-axis. And also, using the right hand rule, since ginamit natin yung staad dito, so, as you can see, papuntang pa ganun yung moment niya. And kung kukunin natin yung right hand rule, ang ibig sabihin nun, eto siya. So, ito yung pwede nating gamitin. And as you can see, this moment will cause a positive moment about the z-axis. Alam natin kasi na paganan yan. And yung thumb natin is magmamark or matuturo on the positive z-axis. Now, we proceed to our two-way eccentricity. Yung two-way eccentricity, ito yung eccentricity na kung saan dalawa na yung ikakos niyang moment. So, for two-way, ibig sabihin, two moments yung ikakos niya. So, ibig sabihin, it's either we have moments about x and we also have moment about z. So, yan yung two-way eccentricity. Dalawa na yung tinitingnan nating moment. And, isa pang sample is kagaya nitong nasa figure. Ayan. Nagkaroon ng eccentricity along x and nagkaroon ng eccentricity along z. Nangyari yon kasi nag-deviate both the z and the x-axis nung center of gravity ng column from the center of gravity ng footing. Kaya nagkaroon ng eccentricity. Remember, dito ina-apply una yung load kasi galing yan ng superstructure. So, kung ita-transfer natin yan papunta ng footing, syempre dito na yan mapupunta. So, syempre yung actual load magkakaroon yun ng eccentricity kung inanalyze natin yun as a pin. So, yun yung galing dun sa principle from our previous video. So, nagkaroon na nga siya ng eccentricity along x and along z. So, for this sample figure, yung rotation natin about x, so since nandito yung load, so papunta yan na pa ganyan. So, yan yung moment about x or moment about z. Kasi umikot yung z-axis natin. And yung moment natin about x is nandito yung load. So, syempre, papunta yan ng paganyan. So, this moment about x. So, for our two moments, so, dun tayo sa moment x. Si moment x is ikokos ng p times dEz. Kasi, ang eccentricity na tinitingnan natin is along z for a moment about x. And for the moment about the z-axis, ang tinitignan nating eccentricity will be x. So this will be p times dEx. So kung kukunin natin yung direction ng moments and also yung signs niya, so si Z is papunta ulit na pa ganun. So kung titignan natin yung samples natin kanina na figure, which is ito, using our right hand rule. So ito siya. So this is the moment about Z. So nag-rotate siya papaganyan. And this will cause a positive moment about the Z-axis. And kung kukunin natin yung X, which is pa ganito, so kunin natin yung X na pa ganito, which is ito. So ang i-cause niya na moment is pa ganyan. So nakaturo ulit yung thumb natin on the positive x-axis. So ibig sabihin, this moment about the x-axis is positive mx, or positive moment about the x-axis. Napakahalaga nito kasi magagamit natin dito kung nasaan, kasi minsan ang binibigay lang sa problem is positive moment yung ganito pero hindi niya idinodrawing. So napakahalaga na alam natin kung nasaan yung positive or ano yung rotation ng positive, kasi kapag kumukuha na tayo nung pressure or yung bearing pressure para dun sa pan-design natin, alam natin kung nasa ng Qmax, nasa ng Qmin. So magagamit natin din dito yung kern distance eh. So alam natin kung saan nakaturo to, nandun yung maximum moment. Kung saan iniangat or yung tail nung arrowhead natin, nandun naman yung aangat at nandun yung Qmin. So ganun kahalaga yung right hand rule, and ganun din kahalaga yung malaman ano yung one way and yung two way eccentricity. So that is all for this video regarding the right hand rule and one way tsaka two way eccentricity. Again, this is Engineer Rodolfo. Thank you for watching, and don't forget to subscribe to Butch TV.